By using the wave provided to us, I'm going to generate a sound wave using Pratt and discuss the process and different techniques for finding the frequency of this particular wave. First, we will open Pratt, click Open on the toolbar, then choose Read from File to open the document Wave 1 from the desktop. Now we'll be able to view this sound in Pratt. Click View and Edit here in the right panel so we can generate the sine wave. The cycles of the wave are more clearly seen by clicking in a few times in order to zoom in closer to the sine wave. The top portion of this entire diagram is known as a waveform, and the bottom portion is referred to as a spectrogram. Right now, a wideband spectrum is visible on the screen. Notice the thick bands. To create a narrowband spectrum, we will go to Spectrum in the top toolbar, choose Spectrogram Settings. In the window length box, we will remove a 0, changing the number to 0.05 and click Apply. Notice what was previously our wideband spectrogram has become narrower, like spaghetti, thus generating our narrow band. Narrow and wideband spectrums have similarities as well as differences. Similarities both being that they are spectrograms showing variations in levels of amplitude of the sound. Also, they are both located at the bottom of the display. Differences in these bands are seen in their visible size. As mentioned, narrow bands are thin, which resemble spaghetti, where wide bands are thicker, which would remind you of a sausage. This analogy is a simple way to remember the differences between these two types of bands. I will now play the sound by going back to the original screen and clicking play. The total duration of this sound is 3 seconds, found here at the bottom of the spectrogram. You are able to calculate the frequency of this sound in 3 ways. The first way is a direct reading from the pitch contour analysis. This blue line shows this direct reading, showing the frequency of 333.3 Hz. The next method utilizes a voice report. Using this method, the frequency can be found by going to the toolbar, clicking Pulses, and making sure Show Pulses is checked off. Next, highlight any portion of the wave, go back to Pulses, and choose Voice Report. The frequency for this method is found here next to mean pitch. The frequency using this method is 333.333 Hz. The final and best way to compute the frequency of this wave is manually by using a formula. We will use 5 consecutive glottal cycles. First, we need to figure out the period of one cycle of the wave. This is done by highlighting one cycle and looking above to find the period. The period is shown here, which is 0.001. Because this is a periodic wave, we know that this same period will correspond to the remaining 4 consecutive cycles. We will then find the frequency of each cycle by dividing 1 over the period, which is 0.001 for all cycles. This will give us a frequency of 1000 Hz for each. We will now find the average of these periods by adding all 5 periods, which would be 5000 Hz. We then divide by how many periods we used, which was 5, to get a total frequency of 1000 Hz for this wave. I will now bring up a table to compare each method of obtaining frequency. When reviewing this chart, it can be said that the first 2 methods derived incorrect frequencies when compared to our manual computing. It is likely that due to parameter settings in the computer and other aspects, it was unable to derive a correct frequency. By being aware of a computer's imperfection and to manually back up our calculations with formulas, we are able to support our findings better than with a simple regurgitated answer from a computer. This helped me to realize that the computer is not always right and to believe in my abilities when calculating aspects such as frequency.